Hello guys and welcome to the Maths and Science Corner once again, and today we're going to be doing probability from mathematics paper 1. So without wasting any time, let's just get straight into it, right? So in question 10, and we have 10.1.1, right? So first of all, let's read the whole question and understand what they want us to do. So flags from 4 African countries, right? So let's just write this down. 4 African countries. So that is four flags from African countries, right? And 3 European countries. So that's 3 flags from European countries were displayed in a row during the 2021 Olympics. So in total, how many flags do we have in total? We have 7 flags, right? Sorry, we have 7 flags, right? So they're saying now determine the total number of possible ways in which all 7 flags from these countries could be displayed. So if you look at this question, we are not given any rules to follow or any order that we need to arrange these flags. We're just arranging them in any way, right? So our total number of ways, so our total number of ways are equal to what? To n factorial, right? So our n factorial is what? What is our n? We said we have a total of 7 flags, right? So that is 7 factorial, right? Which is equal to 5040, right? Ways, right? So let's go to 10.1.2. They say that determine the probability that the flags from the African countries were displayed next to each other, right? So we know that, okay, to find the probability of any event, let's just say A, it is equal to the number of elements or the number of objects in A divided by the total, which is the number of the sample space, right? And we know in this case, what is our sample space? Our sample space is equal to this 7 factorial, the total number of ways without any order or anything, right? So how can we find our number of ways to arrange using this order that they give us, saying that the flags from African countries were displayed next to each other? So we need to find the number of ways to arrange the African countries next to each other, right? So what we do is that we are going to treat the 4 flags from African countries as one thing, right? We're gonna do this, we're gonna treat them as one thing, right? Let's just say this is A1, A2, A3, and A4, right? These are just representing flags. So if we treat this as one item, so this is our first space, right? This is our first space. Then our second space will be reserved for what? For the other flags which are remaining, which are just the 3 European flags, right? So we have 1 and 2 and 3, right? Let me just say E3, E2, E1 is the first European flag, second European flag, and the third European flag. So we have 4 spaces available, right? 4 spaces available. So how can we arrange these 4 items? So this is 2, this is 3, this is 4. How can we arrange these 4 items? We know that, okay, this is equal to what? 4 factorial, right? But then that's not enough, because okay, let me just, before I write this 4 factorial, let me try to explain what is going on here. So right, we have 4 things, right? We have 4 spaces right here. So in this first space, we can either have this item or this item or this item or this, right? So that is the total of how many options? We have 4 options, right? And then we're gonna be left with, because we've used 1 item, so we're left with 3 options and 2 options. Sorry, let me just 2 options and 1 option at the end, right? But we know that in one of these spaces, right, in one of these spaces, what do we have? We have that, and let's just say maybe right here, right? In one of these spaces, we have this item which has four items inside of it, right? Which has four flags inside of it. So that how many ways can we also arrange those flags inside that one thing, right? So we have 4 times 3 times 2 times 1, which is just what? 4 factorial, right? So actually our answer is what? Now we have an answer of what? 4 factorial times 4 factorial, right? This 4 factorial explains how to arrange these 4 items, and this other 4 factorial explains how to arrange inside this one item, which is a group of African flags, right? So that is what it is. So after that, we're gonna go to 10.2, right? So in 10.2, they're saying that A and B are two independent events. So what do we know about independent events? We know that independent events, the probability of A and B is equal to what? The probability of A multiplied by the probability of B, right? So that is what we have. That is what we have for independent events. So they're saying now, okay, we're given that probability of A is that, and the probability of A or B is that. Calculate the probability of B. If you look at this question, what we can do is that we can use the addition law of probability, right? We can use the addition law of probability by saying what? We know that, let me just write this here, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, right? So the A or B is what? It's 0.88. Probability of A is 0.4 plus the probability of B, that is what we are looking for, minus probability of A and B. We know that we say that A and B is equal to what? Is equal to that right here, right? So instead we can have probability of A times probability of B, but we know probability of A is what? 0.4. So we have 0.4 times probability of what? Of B. So we can see that right now our only unknown is the probability of B. So we can just solve for it. If we take the 0.4 to this side, we are left with 0.48, right? Is equal to the probability of B minus 0.4 probability of B. And we have a common factor here, which is probability of B. Then we are left with 1 minus 0.4, right? So now what we have is that the probability of B times 0.6 on this side and 0.48 on this side. Therefore, the probability of B is equal to what? It is equal to 0.48 divided by 0.6, which is, let's type that on our calculator, 0.48 divided by 0.6, which is 4/5, right? We can leave that as it is or write it as a fraction. It is up to you. You can do anything, right? So after that, we're gonna look at question 10.3, right? So for question 10.3, what we have is that, okay, let me just try to create some space here. Okay, so this is our 10.3. So let's see what are they saying in 10.3, right? So question 10 point, let me just write this here, 10.3, right? So what do we have in question 10.3? They're saying that there are 120 passengers on board on an aeroplane. Passengers have a choice between a meat sandwich or a cheese sandwich, right? But more passengers will choose a meat sandwich. Okay, so there are only 120 sandwiches available to choose from. The probability that the first passenger chooses a meat sandwich and the second passenger chooses a cheese sandwich is that, okay, 18 over 85. So now they're saying what? Calculate the probability that the first passenger will choose a cheese sandwich. If you look at this, right, we have a lot of information there. We have a lot of English there, right? So we're gonna try to represent it using we can use a tree diagram to represent the information that we are given and try to see how we can solve it and try to make it a bit simple, right? So that we can actually see what's going on in this problem. So we are given that the first passenger and what? And there's the second passenger also, right? So what happens is that the first passenger has two choices, right? They can either take meat or cheese sandwich, right? They have those two choices, and then depending on okay, if the first person chooses the first passenger chooses the meat sandwich, then the second passenger also has those same options, right? It's either meat also, or they can choose cheese, right? Same thing applies this side. Second passenger can either have the meat sandwich or the cheese sandwich, right? So what information are we given and can we include in our diagram, right? So we are given what they said that um, the probability that the first passenger chooses a meat sandwich and the second passenger chooses a cheese sandwich is 18 over 85. So what is this? What is this probability? So they're saying that the first passenger, here is the first passenger chooses meat and so chooses meat, and the second passenger chooses a cheese sandwich. So it's meat and cheese, right? So it's this probability right here of this part. So we know that we have the probability of that equal to what? 18 over 85, right? So that is the information that we have, and we are also told that more passengers will choose a meat sandwich, right? So what can we do now? What we can do is that we can say that, okay, we know that we have 120 passengers, right? So our total number of passengers is 120, right? We can say that this we can say that we have, let's say, x, right? X people choosing meat first, right? If we were to say, if we were looking at the whole 120 people and say that if a person was asked first to choose out of the 120, how many would choose the meat first, right? So basically that's what we are saying here. Out of 120 people, how many would choose the meat sandwich first? So the x is the number of passengers who would choose meat sandwich first, right? So that is what we have as our x there. So if there are x people out of 120 choosing a meat sandwich first, so how many people do we have left who would choose the cheese sandwich? So since our total is 120, that means we are left with how many? We are left with 120 minus x, right? 120 minus x, all that over 120, because that is our total, right? So now we are saying we have that and we have that, right? So now let's assume that the first passenger would choose the meat sandwich. So what is the probability now that the second passenger would choose meat again, right? The second passenger would choose meat. So now we know that okay, one person has already chosen their their sandwich, right? So how many people do we have left? We have 119 people left, right? If we have 119 people left, and how many people are we choosing from, right? Given that the first person has already chosen meat sandwich, right? How many people are we dealing with now? So we know that the number has reduced by one also, because that's where that's the number we are focused right on, right? So we know that we have x minus 1 people, right? We have x minus 1 people who would choose um meat. And the second passenger, the probability that the second passenger would choose a meat sandwich is that because the total number of people has reduced, and the total number of people who would choose the meat sandwich has also reduced, right, by 1. It's now x minus 1. So if this is x minus 1, we know that okay, we also have our total here is also 109, because our sample space has reduced by 1, right? And we know that the probability here and the probability here, when we add them, they should give us 100. They should give us 1, right? The probability here and the probability here added together should be equal to 1. So how many people do we have that would choose the the cheese the second passenger how many people would choose the cheese sandwich, right, if they were the second passenger choosing? So we know that the number hasn't changed. It's still the same number from here, right? The total number of people who would choose cheese sandwich is still the same. So that is still 120 minus x, right? So from there, I think we have enough information, because remember, we now know the branches that connect to give us this probability, and we know what we are looking for in terms of x. We know we are looking for what? This probability. They said calculate the probability that the first passenger will choose a cheese sandwich. So that means we are looking for this probability, right? This whole thing. So how can we do that? Our simplest way is, because okay, we are looking for this, that means we are basically looking for x, right? So if we can find our x, then we can find the probability here. So to find our x, we know that okay, in order to find this probability, what do we do? It obviously means we took this probability and multiplied it with this probability right here, right? So we have x over 120, all that multiplied by what? 120 minus x divided by 119, right? And that is equal to 18 over 85, right? Right? So what we can do now, we can try to solve for x. We can try to solve this equation by solving for x, right? So the first thing that we can do is, okay, let's simplify this. We have 120x minus x squared all over 120 times 119 is 280, right? This is equal to 18 over 85, right? So what we can do is that we can just cross multiply. So that is 85. We're gonna cross multiply this with this, right, and this with that. So this is 120 times 85. So this is 100. So no, 10,200, right? Minus 85x squared is equal to 14280 times 18, right? So we have 257040. So okay, so this is x, right? Sorry, let me just fix this. So this is 10,200 x, right? So now what we have is negative 85x squared plus 10200x minus 25740 is equal to 0, right? So to solve for x here, what we can do, the simplest way is to just use the quadratic formula, because you can see the numbers are very complicated and too big, so we can use the quadratic formula. So we know our p is 10,200. Let me just type that. And you should find that your x is equal to 36, or your x is equal to let me see, or x is equal to 84, right? So these are your two x values, right? So now, but remember, we were told that but more passengers will choose a meat sandwich, right? We are told that more passengers will choose a meat sandwich. That means the x, which is larger here, would represent the people who choose meat. So this is meat, right? Sandwich. People who choose the meat sandwich, this is our x, right? So that is the x that we're going to use. We're not gonna use this one, right? So what is our probability that a person chooses cheese? Probability of cheese by first passenger is equal to 120 minus 84, all that over 120, right? Which is 36 over 120, which is just 3 over 10.